Hello guys. I'm going to go through my AI project. It's about stress detection. Basically, this system is able to detect when you are feeling stressed in front of your device, preferably a phone or any other device like a laptop. Most of the times we do work, and of course, with time, our concentration span continues degrading and degrading and degrading, and that could cause stress. For example, coders, most of the times when we're under pressure and we are coding, doing a lot of work, sometimes there can come errors and then we feel stressed. Most of the times we get so absorbed in that trying to find the error, but you've heard of some people saying that they go back and sleep, wake up the following morning and they have the solution ready, and when they come just change something small and it works. Yet when we were stressed during that time, we could not be able to see what exactly the problem is. So with this system that can be able to detect stress on your face, um, it can be able to implement this your strategies, your stress relieving strategies. It can suggest the stress relieving strategies that you have, that you usually undertake, such that instead of waiting till that time, probably your stress relieving strategies, a small walk or something of the sort, maybe just to catch some breath for 30 minutes and all that. Just those small things, because with those small activities that you do, you can be able to gain more concentration just slightly. So the stress detection system, as I've mentioned, is able to detect stress. How AI is involved, of course, we are going to be getting data from stress images online. That is, so that we can be able to study and train the model about the human behavior, about how stressful faces look like, or probably also some actions that the user can do with their faces, with probably their body, because shall be seeing this side, probably the limbs or something like that. But majorly it's going to focus on the face, so that we can be able to detect stress from the person when things are really taking a toll on them. So most of it is going to be image data for the face. Data to be used, as I've said, is going to be image, because to help us in identifying multiple facial patterns due to stress. We can be able to learn and understand, train the model how to identify these. So how we're going to achieve this, we're going to achieve it through supervised and unsupervised learning. But just to give you a catch about what these are. So supervised learning, if we look at difference three, it uses input and output data, which we call labeled data, that enables the computer to predict from a test. Let's say, for example, from a test image, it can be able to predict from using the labeled data to use to train it what kind of thing is. For example, now relating it to this stress image, if you put a face that is stressed in front of the, let's say, the image sensor, it can be able to detect that it's a stressed face. That is, uh, for example, when we were feeding in, when we we're training the model, we say that if you see such a face, then it is stress. If you see such a face, then it is a happy face. Exactly. So supervised learning is like that. Unsupervised learning basically is you just give it input data, then it is we leave the AI system to learn on itself the different faces that are being expressed. That is unsupervised. So for supervised, those are these are the differences between supervised and unsupervised learning. Supervised learning is computationally simple because, well, we have already given it, let's say, a basis on how to separate the faces, while unsupervised, we are tasking the computer to do all the computation and look for the even the smallest of differences. Um, Training can be done offline for supervised, because we already have the data and we have labeled it according to the different categories that we need. But for unsupervised, the computer always has to keep on learning and learning and learning, because we haven't labeled the data. So the more it learns, the better it will be able to categorize and accurately get out what we are intending to do here. The third one I've already explained. And the fourth one, we have classification and regression techniques for supervised, and then clustering and association techniques for unsupervised. So supervised learning techniques, as mentioned before, we have classification. whereby the system can be able to classify the different kinds of facial expressions for the user. This is supervised. So basically, it's like getting information from online and then studying them so that we can be able to classify this one's happy, sad, stressed, and all that. One example of classification algorithms, we have linear regression, there is polynomial regression and all that. Sorry, I mixed these two up. Classification algorithms, we have k nearest neighbors, for example. That is one of the classification algorithms. Then for, let me just, oh. So for regression algorithms, we can be able to relate the image data and predict something. It's more of relating two different data sets. So here I say the times when the user is stressed can be related to the image data to predict and pre-recommend stress relaxing activities. So we can compare the image data set that we have that we used to train, and then also the test data, for example, the user, or when we're testing, we subject the system to some stress image. So regression would be able to like kind of draw a similarity between the two and be able to predict and give us the outcome. So regression techniques, we have linear regression. Sorry, I mixed these two up. We have linear regression and also polynomial regression and many others. Those are the supervised learning techniques. For unsupervised, we have clustering and association. Clustering is more like classification, but for unsupervised learning, and association is also more like regression for supervised learning. So clustering, more or less the same. Basically, we feed in image data into the computer and then just let it classify. These ones are happy faces, these ones are sad faces, and all that. So an example of techniques we have of clustering techniques, we have k-means clustering. And now for association, we can relate it to regression, where we can be able to now relate two different times here in the system, two different sets of data here in the system. For example, relating the times when the user gets stressed to the stressful phase you get. So for example, as we continue logging this stress, there could be some patterns that we can be able to get for the times that the users can be able to, I mean that the users are stressed. So we can draw a relation between that, such an unsupervised learning, such that even as the user is in the process of getting stressed, we can be able to suggest even before, based on last time's activities of the sort. So for example, we have the a priori algorithm that can be able to help us in association. So next up, we have the technical challenges. We have a challenge of accuracy. We need a lot of data, as we know that AI is data driven. So when we have little data, then the accuracy is going to be greatly affected. So we need a great deal of data of different faces so that we can be able to analyze. And when we take it now into the real world, it can be able to analyze what? It can be able to analyze the different user faces, and of which we know that these, I can say stressful faces are kind of analog. It's not like on or for this is stressful. Different facial patterns have different features or characteristics or distinctions of stress. So training the model to achieve a personalized experience for the user would be hard. Then also need computation, because studying a user's facial expressions and basically making it more personal, making it like it is a personal friend or someone who's there to tell you that you're stressed. It requires a lot of computation because it needs intense power to do all these algorithmic calculations and everything. Then the skill set, this is my project. I am just trying to see how far I can vision this system or how better I can get at it. Right now, my experience is minimal with moderate mathematical experience, but in AI, it is minimal, but I believe that with time, I'll get the hang of it. So the solutions, we can use supervised learning to gain better accuracy for detection, and then use unsupervised to better personalize the app, better personalize the system, sorry. So when we have, of course, the the faces are not the same as I said, it's more of analog. So we need to make sure that even the smallest detail on a user's face can be detected by the app, because there are some people who give seriously stressed faces, others give minute characteristics of stress on their faces, but basing on the basing on, like, let's say, the feedback from the users themselves, we can be able to detect and personalize the solution for them. Then computational problems, as we said the other side, supervised learning is computationally simple, while unsupervised is more of complex. So instead of diving into unsupervised learning only, we can do both. We can do both supervised to get much of the data that we need to be able to train our model, and then unsupervised for personalization. So that would tend to minimize the amount of computational power that we need to draw from the different systems where it will be running. Then improving skills by reading material and references, of course, to gain better understanding of how AI works, the do's and the don'ts, experiences from past people. Yeah. So when it comes to AI, we have different measures of performance. We cannot only rely on one measure, because one measure alone cannot really gauge how can I say how efficient the system is. So we have four measures. We have accuracy, recall, precision, and F-score. Accuracy is the performance measure of AI that deals with the correctness of the predictions by the AI. Now, of course, sometimes when the AI brings predictions, it's going to mark some things as not stress and it's going to mark some faces as not stress and other faces as stress. But sometimes it might miss the mark. Sometimes it might miss the mark. So accuracy is more of getting the total number of faces that the AI has predicted as stressful and the AI has predicted as not stressful out of the whole data set. That's like a measure of accuracy that we can be able to tell and train and better our AI system. Then recall, it helps us measure how many positive samples were correctly classified by the ML model. So you might have trained this stress system to do some things, but now let's say how best will it recall that yes, this face was actually um this face was actually not stressful. Sometimes it may mark a face as stressful, yet it's not. These two, recall and precision, sometimes confuse. But let me say false negative. What is the false negative in this part? Because the formula is true positives out of true positives plus false negatives. So a false negative is marking, let's say, for example, marking a face that is supposed to be stressful as not stressful, yet it has already learned and predicted that at some point back that face was indeed a stressful face, but the next time we train it, it leaves it out. So that is more of recall. Like, can it remember that such a face was termed as stressful, yet it's terming it as negative, and that's false. So that is something like recall. Recall is basically something like that. Then precision is more of let's say now it brings results whereby a non-stressful phase is brought up as a stressful one out of, like, okay, let's say, for example, precision is a measure whereby it gets the true stress. Now, for example, relating to our system, the true um the true stressful phases out of everything that it has returned. So sometimes, it can return a non-stressful phase, but precision is basically true positives out of true positives plus false positives. Recall is true positives out of true positives plus false negatives. Accuracy is TP. TP stands for true positive, then plus false true positives plus true negatives out of TP plus TN plus FP plus FN. Now the F score is basically the harmonic mean. Sorry, I had a little instability in my network. But resuming back to the F score, the F score is basically harmonic mean. Harmonic mean, let's say, for example, you have two variables, X and Y. Instead of getting the normal mean as X plus Y over 2, we can have harmonic mean as 2, the number of variables, out of 1 over X plus 1 over Y, where it is now 2 out of the reciprocal of the two variables. So that is F squared. So those are the 4 performance measures that we have for the system. Proceeding. So these are the 2 performance measures that I chose for the system that would really determine. So accuracy, how accurate or the correctness of the prediction that of the user's facial expressions down to the level of personalization. That is where I was now bringing up using, where I brought up the thing of using both supervised and unsupervised learning, such that we can be able to personalize the level of accuracy, the correctness of the prediction of the model. Then recall is where we are. The system needs to be able to judge from users' facial expressions that stress is actually present based on the past experiences through unsupervised learning. So recall is like remembering. How able is the system to remember all that we have? So these are the links that I used for my project, and you can refer to them because this is where I got my information from. Thank you for listening.